Dear all, in this session I am going to discuss the important questions from the section of Electrical and Electronics Measurement and Instrumentation. Moving on to the discussion. So before explaining all the questions, let me display all the questions. So kindly answer the particular individual questions accordingly, and it will be helpful for self-evaluation. You know, there are 10 questions which you can expect the similar kind of questions in the forthcoming examination. Also, if you have already repeated in the previous examinations. Okay, you please go through that wherever you want. You can pause the video and note down the proper answer. Once I am going to go for verification, definitely that will help you to have a better revision, and I'll be guiding you how to prepare for the forthcoming examination. So there are 10 questions. Let us see what about the answers. So we'll have a discussion. The first question, I have seen this question in many question papers, especially in the SSC, then junior engineer level examination. Volt ampere method is used to measure dash. So what is the purpose of volt ampere method? Actually, volt ampere method that is most suitable for measurement of low and medium resistance. You can go ahead with option D. Okay. So this is the right answer for this question. Option D, you can go for that. Moving on to the second question. Minimum number of watt meters required for four-phase system. So four-phase is nothing but three-phase four-wire system. Now three-phase four-wire. Let us say three-phase four-wire. Say there are four phases. So let us say n is equal to 4. Okay, I'll be teaching you a shortcut. The minimum number of watt meters required for n number of system, that is given by n minus 1. That is equal to number of watt meter, minimum number of watt meter. Okay, minimum number of watt meter. Please make a note of this, very important. Okay, no need to think for any other concept. Directly you can apply the shortcut, because answer is very important for the competitive examination. So as you can see, there are four phases they have mentioned. Obviously, the minimum number of watt meter is nothing but n minus 1. What is n minus 1? 4 minus 1, that is nothing but 3. The right answer is option B. Please go ahead with option B. So moving on to another discussion. So kindly note down these shortcuts. Definitely that will help you to give the right answer during the competitive examination without the second thought. Question number 3, example of integrating instrument or instruments. So we studied about indicating instrument, then recording instruments, and integrating instruments. Examples of indicating instruments are ammeters and voltmeter. If I talk about integrating instruments, you can say energy meter. It is also known as kWh meter. Then kVARH meter to measure the reactive power. These are called the integrating instrument. Integrating means power into time. So that time integration, summation. Then recording instruments like XY plotter, CR, all are called recording instrument. Now moving on to the discussion. Example of integrating instrument. Identify the integrating instrument or instruments. kWh meter is definitely integrating instruments. kVARH meter is also belong to integrating instruments, but XY plotter is not. It's a recording instruments. So option D, you can check both A and B. So you know kWh and kVARH meters are basically categorized into integrating meters. So better you can go for option D. The right answer for this question is option D. Let me go ahead with question number 4. The characteristics of spring in spring control system. So in measurements, there are two types of control which I already discussed: spring control and gravitational control. So in spring control, it produces the controlling torque. So controlling torque should be equal to deflection torque to keep the pointer at a steady position. Suppose if the pointer wants to go to 0, the deflection torque should be equal to controlling torque. Suppose if the pointer wants to move on to a particular position, you know, deflection torque will be equal to controlling torque. So here the characteristics of spring in the spring control, non-magnetic, it is correct only. Low specific resistance. It should have very less specific resistance. It should have very less value of temperature coefficient of resistance. Then all characteristics are applicable. So it is better to go ahead option C, option D. Option D is the right answer for this particular question. Yes. Let me discuss question number 5. When a multiplier is added to the existing voltmeter, for extending its range, it's electromagnetic damping. Okay, so suppose I have a voltmeter. You can see the voltmeter, correct? Voltmeter, and there is a supply. I need to measure. My requirement is to measure 12 volt. Okay, but unfortunately, the voltmeter can measure only up to 8 volt. What I can do? So I can extend the range. How I can extend the range? So what you can do is a series resistance. You can call RSC, series resistance, that need to be connected with the voltmeter. Fine. So what it is happening? What happened? What happened? 12 volt I have to measure. That is the ultimate requirement. Here it provides a voltage divider circuit, correct? No, till here I can measure 8 volt. Fine. Then by using the series resistor, voltage is getting splitted up. So it creates a drop or it creates a voltage. Okay, so 4 volt. 8 plus 4 is nothing but 12 volt. So the meter is capable of measuring 12 volt by connecting a series resistor with the voltmeter. This is called the extension range of voltmeter. So what is the speciality of this the series resistance? It should have high resistance. Okay, high resistance. So what is the resistance value of voltmeter? It must be also very much high. That point you have to remember. Some questions may be asked in that manner. Now, if I connect a resistance, definitely it reduces the value of total current. If the value of total current is reduced, that means the direct correlation with the torque you can make out. So if the current is reduced, obviously electromagnetic torque is also getting reduced. So we can say that electromagnetic damping will be reduced. Why? Because the deflecting torque value will be reduced as the current goes down. So we can go for option B. Option B is the correct answer for this question. Here also you have to remember one more point. How to extend the range of ammeter. So you have to connect one resistor parallel to the meter so that you can extend the range. Why? Because in case of ammeter, it has very less amount of resistance, less value of resistance. All right. So if you want to increase the value of current, what you can do? You connect a parallel resistor. That is called RSH. Shunt resistors you are supposed to connect to the ammeter so that you can increase the extension range of ammeter. Another question, which one of the following is not an absolute instrument? So you have to study about the classification of instruments. There are different type of instruments. So let us briefly go through the different type of classification of instruments. So secondary instruments, you already studied about indicating instrument, integrating instrument, recording instrument. This is one category. Regarding the absolute instrument, it is basically like a tangent galvanometer, current balance instruments, Rayleigh's current balance method. All are basically called absolute instruments. But in the particular question, if you inspect the given option, it is found that a tangent galvanometer is an example of absolute instrument. Current balance instrument is also another example of absolute instrument. And the Rayleigh's current balance method is also another method of absolute instrument. But KWS meter, I already told you that it's a secondary instrument. In that, we can categorize into integrating instrument. Kilowatt hour meter, it is also known as energy meter. So energy meter, it is an example of integrating instrument and it is not belong to an absolute instrument. So as far as the question concerned, which one among the list is not an absolute instrument? I can go ahead with the KWS meter. I think it's clear to everybody. So moving further, question number 7, you can go through that. Speed of energy meter can be reduced by. So there is one relation. So as you can see, one relation, that one braking torque equation. You have to study one equation, important equation. Braking torque equation, you can write phi m square into speed into the distance with the brake magnet divided by the resistance. Here n is nothing but speed and the d is the distance with the brake magnet. If you talk about the relation between n and d, we can write the n is inversely proportional to the distance. So so what you can do is, if you want to reduce the speed, means you need to increase the distance with the brake magnet. So which option should be the right answer? If you want to reduce the speed is speed implies you need to increase the distance with the brake magnet. So please proceed with the option A. So that relation you have to study. It is very important. It may help you for solving some other type of questions. Kindly make a note of this. Question number 8. It is one of the numerical problem. So first of all, read the question. A meter constant of 230 volt, 10 ampere. It has 800 revolutions per kWh. The meter is tested at a half load and a rated voltage and a unity power factor. The meter to make 80 revolutions in 138 seconds. The meter error is. Okay. So first of all, you have to calculate the meter error. So what is the main equation for calculating meter error? Percentage error that can be written as measured value. Let us write MA. MA means measured value minus actual value divided by actual value into 100. Correct? No? This is the equation for calculating the percentage error. First and the foremost, I need to calculate the actual value. So let us write AV, actual value. Actual value means energy, no? It's energy meter. Energy meter, how to calculate the energy? Power into time, right? Power into time. Power into time. Power is nothing but VI into cos phi. VI cos phi is the power, right? Time, you can write directly. So now let us calculate the actual value of energy. So what is voltage? Voltage is 230. Voltage is 230. Then current is how much? 10 ampere, but they have mentioned that half load because load will be directly impacting the current. So half of 10, half into 10, right? Half into 10 into. What is cos phi? They have mentioned directly that it's a unity power factor. If it is unity power factor, cos phi is nothing but 1 into, what is the time? Time, how much they have given? Time is, just check it up, time is 138 seconds. So you have to convert 130 seconds into hours because it's a kWh meter. 138 divided by, how to convert seconds into hour? 60 into 60. Correct, no? Yeah. So if you calculate, you will get an answer. So say, let us compute, you will be getting 44.08. 44.08. Okay. 40.08. What is the unit? It's energy, no? Kilowatt hour. This much of kilowatt hour you will get it. Next, what I'm going to do is I'll be computing the measured value. How to calculate the measured value? Let us write MA, measured value. Measured value is nothing but revolution per kilowatt hour. Revolution per kilowatt hour. Okay, revolution per kilowatt hour. So how many revolutions happened? There are 80 revolutions, right? 80 revolution divided by kWh. It is 1800. Already given in the question. Please read 1800, right? 1800. So if you calculate, you will be getting around 44.4 kilowatt hour. 4 kilowatt hour. So I got measured value and actual value. Definitely, if you know these two parameters, you can calculate the percentage error. I'll be writing the percentage error. It is nothing but the measured value. What is measured value? 44.4. 44.4 minus what is actual value? 44.08. No, 44.08 divided by then what is actual value? Actual value is same only 44.08. 44.08. That should be multiplied with 100. So if you calculate, you will be getting the answer is 0.817%. Okay, this much of percentage you will get it. The conclusion is the difference you can see the measured value and the actual value. Okay, measured value, measured value and actual value. The difference between the measured value and actual value, that is positive only. If the measured value and actual value difference is positive, definitely we can say that the meter moves very fastly. So I can go ahead with the option B. Option B is the correct answer. I hope you got the point. Yes, these kind of questions will be repeated because of energy meter. There are different type of numerical example. One more type numerical example will be there. I'll be working out in the another video. Okay, so here you can work out. Now we can check it up. Another question. Identify the incorrect statement on dynamometer type wattmeter. Dynamometer type wattmeter. So you have to take care about pressure coil, then current coil. Okay, pressure coil. Pressure coil will be the current coil will be the. See, you can see this is your current coil. This will be the pressure coil. Current coil will always connect series to the load. Pressure coil will connect across the load. That point you have to remember. Number one. So number two, both current coil and pressure coil are air core type material. Air core. There is no iron core. So that hysteresis loss will be very less in case of dynamometer type wattmeter. Then in order to get the maximum flux division, what you can do is the pressure coil will be connected at the mid of current coil to get the equal flux distribution. So look at the question. Identify the incorrect statement. So fixed and moving coils are air core only, correct? Fixed coil is connected series to the load. That is also absolutely right. Then altogether we can say that hysteresis loss will be reduced. But hysteresis loss will be reduced. But here they have written as high hysteresis loss. Look at this. Then last point is moving coil is connected across the load. That's also correct. All are correct only. But option C, that is violating the statement. That is an incorrect statement. So they are written as high hysteresis loss. Hysteresis loss will be reduced, no? So option C is the correct answer. Please opt option C. Let us have a discussion on last question. Dash bridge is used for measuring a low value of inductance. There is one code you can remember. OAMH. OAMH. O stand for Ohm's bridge. OWENS. Ohm's bridge. A means Anderson bridge. A implies Anderson. Anderson bridge. What is M stand for? M stand for Maxwell. Maxwell's bridge. Maxwell bridge. S stands for Hayes bridge. Hayes bridge. For Hayes bridge, H is there now. It is suitable for measuring high value of inductance. That is right. High value of inductance. Even quality factor is also high, more than 10 quality factor. If I talk about Maxwell, M means medium. Okay, medium value of inductance. So here, Q value varies between 1 and 10. If I talk about the Anderson type bridge, the Q value that is less than 10 only. Okay. Even Ohm's bridge also used for less value of inductance. Here, which is the right answer? Dash bridge is suitable for low value of inductance. Ohm's bridge. Fine. So you have to remember the code OAMH. Okay, OAMH. Then you can solve this similar kind of problems, similar kind of theoretical type questions in the competitive examination. So if you are having any questions, please put up in the comment box. So thank you for listening this video. I'll be coming up with similar kind of questions in the next session. Kindly like, share, subscribe, and give your valuable inputs for our improvement. Thank you so much for watching this video. Happy learning.